Good morning, students. In this session, we are going to discuss about alloy significance and its applications. The course outcome of this specific topic is explore the chemistry behind the technology of building materials, and the learning outcome is at the end of this lecture, student will be able to acquire the knowledge of alloys and its importance in construction discipline. An overview of this particular topic is introduction, properties, types of alloys, significance, pros and cons, industrial application of alloy materials, applications in construction discipline, and alloy steel. Introduction. What is the method of preparing alloys? So alloys can be able to prepare by various methods. In that, the first one is made by combining two or more metal elements while in molten state or by bonding metal powders. Normally, metal powders with high surface area is having a more tendency to get involved in fusion and leads to the formation of alloy material. So the size of metal particle also plays a major role in deciding the alloying process. Number two, made through by some physical process and determining the physical and chemical properties. Why alloys? What is the purpose of alloys? To increase the hardness as well as the strength of metal, to prevent corrosion or rusting, to improve the appearance of metal surface. Alloying is nothing but it's a combination of one or more metals or metal with some non-metals. As an individual metal, it should exhibit some specific property. Sometimes if the metal is exhibiting a very good hardness, then there may be a corrosion problem. Suppose the material is having an anti-corrosion property, then the strength won't be that much good. So in order to accumulate all the properties of material, so fusion of different metals with non-metals is necessary. So here the main aim of alloying is to increase the three basic condition properties, that is hardness, strength, corrosion, and then appearance on the metal surface. What are the properties of alloys? The major 5 properties of alloys are strength, conduct electricity, durability, resistance of corrosion, ability to withstand heat. What are the types of alloys? Cast alloys, bearing alloys, corrosion resisting alloys, superaustenitic stainless steel alloys, normally used to call as SAS alloys, high strength corrosion resistant alloys. What are the major significance of alloys? The major significance of alloys includes increase the hardness of metal. How to increase the hardness of metal? It's a simple fusion of two metals or with the non-metals based on the requirements. Number 2, lower the melting point of metals. And number 3, increase the corrosion resistance of metals. Number 4, modify chemical activity of the metal. Sometimes a pure metal may exhibit some good catalytic activity, or it may not exhibit any catalytic activity. By getting involved in the fusion with some other metals or non-metals, the catalytic activity may get enhanced or it may get suppressed, and that too depends upon the requirement. Modify the color of metals. Depends upon the need of color, you can able to fuse a metal with a different materials so that to achieve the desired properties. To get good casting of metal. These are the major significance of alloys. What are the pros and cons of alloys? It's low cost and density, good castability, low hardness, suitable for long-term usage, and the cons are discoloration, high CT, may form internal oxides, and the internal oxide formation is due to the entrapment of oxygen into the metallic structure. This entrapped oxides is combined with the metal and leads to the formation of different oxides having a different oxide state of metals. And finally, should not cast in a carbon crucible. The reason is when the material is casting in a carbon crucible, the carbon also get entrapped into the interstitial site of the alloys and leads to the formation of carbides. These carbides may disturb the property of the materials. Industrial applications of alloys. There are some major metal which plays a vital role in the alloying process. In the number 1 is magnesium, number 2 is copper, aluminum, steel, and nickel. Application of alloys in construction disciplines. Normally, alloys are make use in almost all the disciplines, but of more specific, construction discipline plays a vital role because here's only almost all the properties of the alloys is getting utilized. Steel is among the most popular material used in the construction industry. According to the World Steel Association in 2018, around 1,808 million tons of crude steel was produced worldwide, and about 50% of production were utilized by the construction industries. Around 3,500 different grades of steels available, and each grades offer environmental, chemical, and physical properties unique to the grade of steel. Again, the property of steel plays a vital role in deciding the alloy's nature. That may get vary depends upon the material get fusion with the steel. Maybe the percentage of carbon get varies, maybe the chromium content varies. Based on that, we are able to develop the different grades of steels, and that too depends upon the requirements of the desired properties. What are the types of steel? Fundamentally, steel is an alloy of iron with a low amount of carbon. There are thousands of different types of steels which are created to suit different kinds of applications. Steel alloy are broadly classified into following. Number 1, carbon steel, tool steel, stainless steel, alloy steel. Carbon steel form the majority of the steel produced in the world today because the percentage of carbon only increase the strength of the steel. Tool steel are used to make machine parts, dies, and tools. Stainless steels are used to make common household items. Alloy steels are made of iron, carbon, and other elements such as vanadium, silicon, nickel, manganese, copper, and chromium. Now here we highlighted the difference between the alloy steel as well as the non-alloy steel. Let us have a look regarding the alloy as well as the non-alloy steels properties wise. Alloy steel is a type of steel composed of iron. The majority of the alloy steel, the major composition element is iron and carbon. As I discussed earlier, carbon increases the strength of the steel. Whereas in non-alloy steel, it's a type of steel that has no long other elements added during smelting process. And again, alloy steel composed of high amount of carbon content, whereas in non-alloy steel has low or no carbon content. Number 3, made by adding different elements during smelting process. Here no other elements are added during smelting process. Number 4, less resistant to corrosion due to the presence of iron. Highly undergoes corrosion due to the high amount of ions. Because in this stage we are mixing with some other materials to avoid the corrosion property. Whereas in the non-alloy steel, we are not adding any other elements as we discussed in the third point, because during the smelting process, we used to add a lot of elements to increase the desired properties. Whereas in non-alloy steel, we are not doing like that. So hence the corrosion resistance is less. And the best example for alloy steel is stainless steel, whereas the best example for non-alloy is wrought iron. What is the effect of alloying? Alloying elements can alter carbon steel in several ways. Number 1, alloying can affect microstructures, heat treatment conditions, and mechanical properties. Today's technology with high-speed computers can foresee the properties and microstructures of steel when it is cold form, heat treated, hot rolled, or alloyed. For instance, if the properties such as high strength and weldability are required in steel for certain application, then carbon steel alone will not serve the purpose, because carbon's inherent brittleness will make the weld brittle. The solution is to reduce carbon and add other elements such as manganese or nickel. This is one of the way of making high strength steel with required weldability. So basically, depends upon the requirements, we are varying the ratios of carbons and different alloying elements to achieve the desired properties. What is the effect of alloying element? During the process of alloying, we are mixing the alloying with the different elements to achieve the desired properties. In that, here we highlighted some specific elements and its responsibilities in achieving the alloying is listed here. Let us have a look on that. Number 1, aluminum. Aluminum content can rid steel of phosphorus, sulfur, and oxygen. Chromium can increase toughness, hardness, and wear resistance. Copper can increase corrosion resistance and hardness. Manganese can increase high temperature strength, wear strength, ductility, and hardenability. Nickel can increase corrosion, oxidation resistance, and strength. Silicon can increase magnetism and strength. Tungsten can increase strength and hardness. Vanadium can increase corrosion, shock resistance, strength and toughness. Alloy steel products and its applications in construction field. Okay. Alloying elements can alter carbon steel in several ways. That is, as we discussed, microstructure, heat, treatment, all those things. Of more particular, these alloying elements provide the desired properties for the construction field. There are hundreds of products that can manufacture with the alloy steels. These include alloy steel pipe tubes, alloy steel plates, wires, steel forge fittings, alloy steel bullets, and they are used in various industries such as automobiles, mining, machinery, equipments, all those things. Of more particular, what is the application of alloy steel in building large structures? More. In building and construction industry, alloy steels are used for very large modern structures such as airports, bridges, skyscrapers, and stadiums in the form of steel skeletons. Alloy steel provide the required high strength to support such large structure. Even concrete structure use alloy steels as reinforcement to add strength and reduce the overall weight of the structures. Number 2, alloy bridges. Bridges use special alloy steels known as weathering steels. These provide enhanced protection from corrosion because of presence of nickel, copper, and chromium as alloying elements. Weathering steels also find use in buildings as facing material to improve aesthetics, high safety, and quickness of construction, aesthetic looks, shallow depth of construction, low maintenance, and amenable to alteration in the future. Because of its natural weather finish, no painting is required, thus avoiding environmental issues caused by paints. So weathering steel plays a vital role in the environmental aspects. Alloy steels are used to make flat products such as plates and strips. Plates are available in a wide range of grades and sizes. They are used in building construction by welding plates into fabricated sections. Alloy steel strip and coil products. Strips are available as hot and cold rolled strips and hot dipped galvanized coils, or sometimes hot dipped galvanized coils are used to make construction products that includes wall and roof cladding, slate rolls, roof purlins, light steel frameworks, and lintels. Alloy steel flanges are used in stainless steel pipelines. Alloy steel products are used in construction industries such as grinders, structural sections, bars, roads, rails, rods, and wires. And the price of alloy steel. Since alloy steels have specific properties needed for specific application, prices vary greatly based on the grades comprising composition of alloying elements. The variation in the grade depends upon the combination of different alloying materials. As a whole, the combination of materials decides the price of the materials. The price of alloy steels available in India typically vary in the range of rupees 90,580 per ton to 4,08,000 per ton. As can be seen from the foregoing, alloy steel plays an important role in the building and construction industry as well as other industry. Alloy steels offer economy, high performance, corrosion resistance, durability, high strength to wear ratio, high performance under harsh condition, and a wide variety of products to suit more applications. So as a whole, alloying is the process of more importance in various disciplines, particularly in the construction field, to decide the properties. Thank you.